Hello everybody, welcome back to my channel. In today's video, we'll be seeing conductometric titration. This is the first time I have made a video on this topic, so I'll be going a little slow, and it'll be like I'm learning with you all. So in that manner of understanding, I'll teach you. It's a slightly harder topic as well compared to the other topics which we have covered. So conductometric titration, let's learn the principle first. Don't need to by heart own words. It is a principle in which conductometric titration is based on the change in the conductance of a solution during titration. Okay, during titration, ions present in the solutions are replaced by other ions having different ionic conductance. Mostly highly ionic, right? Mostly, okay, one kind of ion substituted by another kind of ions. So, because of the different ions conduct electricity differently, the conductance of the solution changes continuously. Or can I say it like conductance of electron depends on the nature of ions, mobility of ions, and number of ions. That also is important at one point, alright? Conductance depends on number of ions, mobility of ions, and as well as the nature of ions. Okay, so if one kind of ions are substituted by another kind of ions, the conductance may increase or decrease. That is the basic principle you have to keep in your mind. Okay, so the graph is plotted between conductance and volume of titrant added. We come to that. Coming to the theory, now it's a small derivation which I would like to practice with you all. So once you guys can see what is happening, this session is going to be purely like I am learning with you, because it's a hard topic for me as well, but we have to learn it, right? And it is important for the upcoming exam, so let us do it. Conductance is the ability of solution to conduct electricity. Conductance is the reciprocal of resistance. This we know. Conductance, resistance. Okay. Unit is Siemens. This thing you have to remember if you know well and good. Siemens inverse. Okay, Siemens inverse. This much is also clear. Now let's derive this conductivity, which is kappa, which is also the specific conductance. Let's say conductivity itself. Okay, so resistance is directly proportional. We know that R is equals to rho L by A. From this we can say R is directly proportional to L by A. Done. This we know. The formula R equals to rho L by A. What not they have told here. Okay. From this we can get this. Removing this side, we will take everything else that side. We will get this. Next, this part we have to know. We need conductivity. So we have to take 1 by resistivity, because conductance is 1 by resistance. Got it? Then if rho is this, 1 by rho value you can substitute over here and you get kappa. Now we know conductance is units derivation. Let's go to see units derivation. So the formula we got 1 by r, 1 L by Ra we got. So R is, we know it is ohm, so 1 by ohm. L is centimeter square, so then we get the unit of this. Now I want us to practice this once. Here we have done. Let's quickly practice it. It won't take much time, so that I can explain it to you as well how we are doing. Okay, so first step is R is directly proportional to L by A. This is correct. Till this much we know, right? R is directly proportional to L by A. How will we get? R is equals to rho L by A. Rho is equals to Ra by L. Kappa, I hope we write like this only, is equals to 1 by rho. Because we know C is equals to 1 by R. So conductivity is equals to 1 by resistivity. That is equals to 1 by Ra by L. That becomes L by Ra. So kappa is basically equals to 1 by R into L by A. So conductivity is equals to 1 by R is what? 1 R is resistance. 1 by, okay fine, let me show you once, then I think you'll understand better. Here only, conductance. See, 1 by rho is conductivity, 1 by R is conductance, L by A is cell constant. Okay, so conductivity is equals to conductance into cell constant. Till here it is clear. K is same as 1 by rho. This I have shown here. So basically, why did we write this? So that we can get rho. From rho only everything will happen. Okay. Let's try to derive the units of this. So we know K is equals to 1 by R into L by A. That becomes 1 by ohm centimeter by centimeter square. That becomes ohm inverse centimeter inverse. That becomes this much also we can write and leave, or S inverse centimeter inverse also we can write. I will just leave it till here because it's more derivable, right? Instead of by heart time we can derive it. So this is the derivation which is important, comes under theory itself. Okay, so till here finding resistivity, all of this, see, so to 3 pages it took us 3-4 pages. It's just nothing but this part, this much part only. Okay, so don't get stressed by the number of pages. Now coming to instrumentation of conductometer, just imagine, just try to remember it. Okay, there's a conductivity cell. Conductivity meter will always have a conductivity cell, 2 platinum electrodes. Each electrode is of 1 centimeter width. Each electrode has 1 centimeter square area, and they are placed 1 centimeter apart. The cell is dipped into the electrolyte solution. The cell is connected to the conductance measuring device. Conductance measuring device is also there. Okay, so once again I'll repeat what all is there. First of all, a conductivity cell is there, which has 2 platinum electrodes, and the platinum electrodes are of 1 centimeter square area. They are placed 1 centimeter apart. The cell is dipped in the electrolyte solution, and this is the whole system is cell is connected to the conductance measuring device. This much is clear. Working. AC current is passed through the solution. Current is passed through the solution. So when current is passed through the solution, the conductance is measured. Using cell constant, conductivity is calculated. Yes or no? Above only I showed. Using cell constant, conductance is measured. So using cell constant, we can calculate conductivity. Okay. So usually the meter directly displays a specific conductance. Current is passed, conductance or resistance is measured. Using cell constant, we can measure the conductivity. Usually displays measure shows the conductivity directly. That's it. Very simple. Instrumentation also done. Now what remains is the main part. From here it's even more important. Till here it was important, yes. From now on even more important. So pay even more attention. We'll go very slowly. Okay, we'll go very slowly. The first, there are 4 cases: strong acid, strong base; weak acid, weak base; strong acid, weak base; weak acid, strong base. Each one will cover very slowly. Sometimes you might get confused, but I'm trying to learn it up quickly and just move on. Don't take too much out of it. Okay, so strong acid, it's easy, but since it's the first time, it'll take time. Strong acid versus strong base. So what? HCl versus NaOH. Okay, this much you got an idea. So HCl I'm writing it as H plus Cl minus, NaOH I'm writing as Na plus OH minus. It is after the reaction takes place, after titration, say NaOH we're adding, right? So after that, what is happening? NaCl and H2O is being formed. So before equivalence point, before reaching the equivalence point, what is happening is HCl solution contains high conducting H plus ions. Highly conducting H plus ions are present, so the conductance is high. On adding NaOH, what happens? The H plus ions combine with OH minus ions to form water. Okay. Initially, H plus Cl minus, Na plus OH minus was there. Initially H plus concentration was high. When we add Na plus OH minus, this OH minus reacts with this H plus. It forms water. And this Na plus Cl minus is there, right? Na plus Cl minus. So basically what is happening? This Na is replacing this H plus. On adding NaOH, H plus ions combine with OH minus to form water. H plus ions are replaced by Na plus ions. Okay. Na plus ions conduct less than H plus ions, hence conductivity decreases. First, did you understand why conductivity is decreasing? See, whenever writing these answers, you should not start directly what is done before titration. Before titration, obviously only H plus ions, the conductivity is high. That nobody is asking you. We are doing only after titration starts. That time only we should consider. That one thing you have to remember. Not before anything happens, you're simply sitting idle, then what's happening, that nobody is asking you. Okay. The video is getting lengthy, but still I want to complete it. Okay. It'll take time. I told you in the beginning itself. So, firstly, only HCl was there. That time NaOH we started adding, slowly started adding. H plus is getting replaced by Na plus. So H plus was more, had more, H plus is more conducting. That is replaced by less conducting Na plus. So conductivity decreases. Then equivalence point is reached. In equivalence point is what happens? Totally H plus is totally gone. Now it's only Na plus Na plus. Only Na plus. All H plus ions are neutralized. Conductance becomes minimum. After equivalence point, still we are going on adding NaOH. We are not stopping adding Na just because it has decreased. We are still adding. Now the solution has been increasing OH minus ions. Again, OH minus ions are very mobile, have high ionic mobility. So conductance increases sharply. This is the equivalence point. This is the conductance. This is the volume of NaOH. First it decreases. Why it's decreasing? Because I'll read it out. The highly conducting H plus ions initially present in the solution are replaced by Na plus ions having much smaller ionic conductance. You can use such words. Small ionic conductance. Therefore, the conductance first falls, and after the equivalence point has been reached, rapidly rises with further addition of NaOH, which furnishes Na plus ions and OH minus ions. The intersection of the two lines gives the endpoint. Like this also in own words you can write. Okay. First case is strong acid rock base. I hope you have understood it well. Let's come to the second case. That is strong acid and weak base. Strong acid and weak base. Example, what are we taking? HCl and NH4OH. Revolve around these only. For weak acid, we can take CH3COH. Revolve around these four acids only. I'll just write it somewhere over here. For HCl, NaOH, NH4OH, CH3COOH. Strong acid, strong base, weak base, weak acid. Use these only for taking example. Don't get confused. That way you can learn the example. So H plus Cl minus H plus Cl minus plus NH4 plus OH minus. Now what is going to happen? NH4 plus will take the place of H plus and this will form water. So first of all, initially highly conducting strong acid was there. When weak base was added, what is it doing? NH4 is H plus ions are replaced by NH4 plus ions, and NH4 plus ions have lower conductance, so conductivity is decreasing. At equivalence point, the HCl is completely neutralized. After equivalence point, what is happening? You are going on adding NH4 plus NH4OH minus NH4OH are going on adding that base, but it is a weak base. It ionizes only slightly. presence of NH4Cl. NH4Cl is there, right? It suppresses the ionization. That one point you should remember. When strong acid weak base case is there, that time NH4OH are adding after equivalence point, no doubt. But the NH4Cl which is present, that is suppressing the ionization by common ion effect. Just remember theory. Hence, very few extra ions are produced. So, the conductance remains almost constant. This conductance is volume of NH4OH, and this is of strong acid weak base condition. Okay, I'll read it all once. The highly conducting H plus ions are initially present in the solution are replaced by NH4 plus ions having much smaller ionic conductance. Therefore, the conductance first falls, and after the equivalence point has reached, the conductance almost remains constant. Since the excess of ammonium hydroxide added do not ionize in the presence of ammonium chloride because of common ion effect. The plot is curved near the end point due to hydrolysis of salt of strong acid weak base NH4Cl. That curved near the end point due to the hydrolysis of the salt of strong acid and weak base, that I will not really mention here. Okay, I will not really mention it here because it's kind of confusing. This much is well and enough is what I feel. Okay, next coming to the weak acid strong base. Weak acid, what did I say? We'll take CH3COOH and base NaOH we can take. So this I'll write as CH3 plus. Okay, sorry, H plus CH3CO minus, my bad. Completely I would have changed the reaction. So H plus CH3COO minus plus Na plus OH minus. This will give us what? Na plus CH3COO minus. Okay, Na plus CH3COO minus. Basically CH3CONA and H2O. This also we can add CH3COOH plus NaOH plus H3CONA. So first what is happening? Initially CH3COOH is a weak acid. It ionizes, it only slightly ionizes. So therefore initial conductance is low. As NaOH is added, sodium acetate is formed, which is more conducting than this one, acetic acid. So that time it increases. Then what happens? After this what happens means, sorry, I was seeing something else. So this you understood, CH3CONA is strong L, right? This dissociates completely into ions, no need to mention, but okay, so it's basically ionic. So conductance, number of this dissociates completely into ions. CH3CONA plus H3CO minus plus Na plus, number of ions increases, so conductance gradually increases. At equivalence point, acetic acid is converted into sodium acetate completely. So after the equivalence point, when NaOH enters, OH minus, so it increases rapidly. First it was increasing slowly, then it increases rapidly. I'll explain to you now clearly what is happening. At this point, what is happening means CH3COH which was there, in that H is replaced by Na. So CH3CONA. First CH3COH is a weak acid, it doesn't ionize, so it has low conductance. So when we add NaOH, that CH3CONA is more, it can dissociate into ions completely. That's the reaction you have to remember in exams. It can dissociate into ions completely. So that time, what so that means it number of ions increases, so conductance increases gradually. After that, at equivalence point, as antiacetic acid is converted to sodium acetate, or so that time after equivalence point also, when we continuously add NaOH, the number of OH minus ions are highly mobile, so conductance increases rapidly. Number of ions is for some reason, highly mobile is for some reason, and Ionic mobility is also for some reason. Now coming to the last one, which is weak acid, weak base. Okay, CH3COH and NH4OH. So CH3COH and NH4OH. First of all, this is a weak acid; it will not neutralize. This is also a weak. So CH3OH and NH4OH are weak electrolytes. Initially, content is low. Even when NH4OH is added, ammonium acetate is formed. This salt is more ionized than the weak acid. So conductance increases slowly. Ammonium acetate is present in the solution and the point is obtained. Excess NH4OH excess NH4 is weakly ionized. So therefore very few ions are produced. Therefore conductance changes little to no change. So first of all, slight increase, then almost no increase is what is going to happen. So I've tried to cover the points. It might be kind of confusing. So hope you liked it. Thank you for watching. Bye bye.